Good afternoon, ladies and gentlemen. And we're in the City Hall, and we're here with the man who's running the City Hall, who's running the city. It's the mayor of Remscheid, Burkhard Mastweis. And I'd like, before we continue our first in a nutshell session for the cement chapter, I would like to give the word to you, thanking you, Burkhard, for the strong support we're getting from the city.
Yeah, Peter. Thank you very much for your job. Dear guest, welcome to my town. We are really proud that the climate conference takes place for the third time here in Remscheid. My thanks go to Peter and the whole team from FCA for the successful job. Thank you very much, Peter. As you have seen, our town is an industrial town. Our history is directly related to the development and production of tools. Formerly operated with hydropower, have we today modern companies whose products are valued worldwide. It is for our companies of an essential importance that we find ways to be able to produce a climatic neutral manner in the future. Also, the city is facing up to the ask to make a commitment contribution to a future with more climate friendly. We work in different fields, especially on mobility and municipal heat planning. It is of our considerable importance to take the people of our town with us. I'm a very lucky grandfather of 3 little boys with 3, 2, and 1 year. It's my wish and my task to enable not only these 3, but all the children of our world a good future. No more and no less is our responsibility. Thank you very much and welcome to my town.
Thank you very much, Mayor Mastweis. Okay, let's jump right into the topic. I've brought with me a very much appreciated member of the Future Cleantech Architects crew. It's Dr. Antoine Cohen, who is running or is responsible for the whole cement chapter, because we said these chapters, cement, long duration storage, aviation, and innovation, are so complex. We need a chapter lead. We need a specified member of our team who has prepared this over months. And in this case, it's Antoine. So Antoine, thank you for joining us here.
Thank you.
And what we'd like to do is do a little in a nutshell session. We'd like to give you an overview of where we are in cement right now, correct? Good. We want to talk about cement. Why is cement such a tough problem? Before we kick off with the first high-level panel on this, or technical panel. And for that, we have brought a little overview. Because Antoine, concrete is everywhere, correct? We find it in any of our infrastructure, basically?
Exactly. It's in our buildings, it's the infrastructure, residential, non-residential. It's the building block of modern society, and it's sort of very hard to live without it. And the problem is, it's everywhere, and it has a very high emissions associated with it.
So it's 5% of CO2 emissions, of CO2 equivalent emissions. If we look at CO2 only, it's even more, right?
Yeah, it would be 7 to 8%, which is usually the figure people hear. In terms of, CO2 equivalent, that's about 5%, which doesn't sound like much, but that's in itself, by itself, a big chunk. And most importantly, it's a chunk where we're not on track, if we look at the trends that we're on right now. And if we're not on track for 2 reasons in terms of the emissions associated from the sector. It's not only the emissions intensity of producing cement, which is the fundamental ingredient of concrete. The emissions intensity has still been rising over the past few years, but also the demand for concrete has been rising and is going to continue to rise because it's key to economic development and growth. It's very strongly correlated with that. So when you combine the 2 of those, we're not only not decarbonizing cement, at the moment it's still putting more and more emissions into the atmosphere.
Thank you. And maybe we take a look at why it's so hard to decarbonize it and why alternatives are relatively hard to be put in place. And that has to do, and we are pleased again to have several policymakers in the room. That has to do with the source of the emissions. Say we found a way to decarbonize the firing process of calcination. We'd still have a lot of emissions, correct?
Exactly. So cement is a particularly hard problem because it's not just about energy. It's not just, oh, how about we have, you know, a renewably powered cement plant that'll solve the problem. No, because the emissions, about 60% of it comes from the fundamental chemical reaction to make cement, a reaction called calcination. That releases a lot of CO2, and then, so that's about 60% of the overall emissions. Then you get about 30% from the heat that you need to provide to your plant, which is at very high temperatures, which is also very hard to decarbonize. So a complex emissions profile, which makes it, you know, hard to decarbonize.
And then, in addition, as you've mentioned before, it's so essential to development, to urbanization, to heavy infrastructure, all these kinds of things. And the process has been developed and optimized for a century. So it's a very established process. And I know we have a lot of journalists, innovators, corporate players in the room who work on these topics. But it's, I think, good to sort of have a common understanding of that. So it's process emissions. It's the second most used material in the world after water, basically. And even, I mean, we started saying, could we decarbonize at least the firing process? Even that is a tough nut to crack, correct? Let's look at the next slide, maybe.
Exactly. And so we're not here just to talk about sort of the problem. We want to really look at the solutions. And the thing is with cement, since, you know, it's a complex topic, complex sources of emissions, there's not just one solution, one size fits all. This is the way forward. There's sort of multiple approaches that all have to be combined. It's a mix and match. It's both how do we reduce the demand for concrete by being much smarter in how we use it. It's how do we get rid of the fossil fuels or do CCS on the emissions from that. Or how can we even play around with the recipe for concrete, use different materials that might be less carbon intensive. It's a bit of everything. And that's what you're going to see, I think, this afternoon in all the different sessions we have, a glimpse of all these solutions.
So we, in total, even though attention for this topic is rising, we still consider this sector massively neglected in terms of funding, R&D, in terms of implementation, green public procurement, policy tools, a lot of things that can be, a lot of stuff that can be done. And somebody, I was speaking to an expert this morning who said that their organization is convinced that it's almost a fight of the new concepts is now going on for alternatives to cement, for decarbonization pathways, carbon capture and storage, alternative building materials, so much interesting. And we've structured the chapter accordingly. So we want you to take away from here, from the ARC Festival, ideas and inspiration and facts and pathways on the most important parts, on the most important challenges. And sorry, surprising Simon now, the stage manager. Can we switch to the agenda one more time? So maybe Antoine and I can, yeah, I hear him cursing, but. So we'll start with a specific panel of what could be beyond Portland cement, so the dominant cement type. And I see new members to this panel are just arriving. Thank you very much for taking the trip. And so as Simon is moving in here, yeah, this is still the innovation chapter. Here's the cement chapter. Maybe you can zoom in even a little closer. So Antoine, give us this is your chapter. Give us a quick run through. What's the plan here?
Yeah, so we'll kick off with a panel on, like Peter mentioned, going beyond traditional ordinary Portland cement. So in the broadest sense possible. So in parts sort of materials, can we, you know, try different supplementary cementitious materials, add mixes, all these things, and also Herr Rehbaum coming to talk about his plans in his region for cement and how to decarbonize it. We'll move then into two parallel sessions, one on the specific challenge of high temperature heat, where we have two presentations, and then the other for policymakers specifically want to help them sort of give them tools and actionable things that they can do to help the sector move forward. And then we'll finish off with two equally important sessions. One where we want to focus on the African continent and the sort of specificities there, because we're in a very Eurocentric context here, but there's a lot of growth projected for Africa, and we need to figure out a path forward there. And the last session is rethinking construction. This is being a bit more out of the box in how we approach reducing demand for concrete, both through efficiency and through substitution with other materials. So as you can see, very diverse set of sessions.
Correct. And a promise at the end of this, which is a shuttle bus leaving at 6:50, taking you to Schützenhaus reception afterwards, those who've been invited and registered for that. Thank you very much. Housekeeping rules, all moderators, we would kindly encourage to stick to the timing. So as we just tried to do, Antoine, we're almost done. And from here, I would say let's take it to the first panel on what's beyond ordinary Portland cement. Thank you everybody for being here, and we look forward to the discussions this afternoon.
Thank you. And let me, it's my pleasure to introduce our moderator for the session, Feladi Tlala from the Federal Institute of Materials Research and Testing in Germany. Thank you so much for accepting to moderate our opening panel. I'll invite also our panelists to come and sit at the front. And we can begin as soon as you're ready.
Thank you, Antoine, and please may our Good afternoon, everyone. So welcome to the most important session of the day, which is all about cement. Cement is fun. I would firstly just like to welcome our panelists and our guests here. So I'll just name them, and they will raise their hands because they're not in the order that I thought they would be. To introduce myself, my name is Peladi Tlala. I am from South Africa. I work for the Federal Institute for Materials Research and Testing, formerly known as BAM. I just don't know how to say the German word properly, so I don't want to butcher it. And I work for the Department of Construction Technologies at BAM, and that is about me. So just to introduce our guests, Henning Rebam, he is a member of parliament for the German member of parliament here, and Ms. Good afternoon. Ms. Stefan Gerhardt from Ecoloct. She is the co-founder of Ecoloct. Good afternoon, ma'am. And Mr. Barney Shanks from Ceratec Cement. He is the CTO of Ceratec Cement. And Mr. Andres Kunzmann from Polycare. He is the managing director. So we thank Antoine, and I'm guessing I'm supposed to sit down. So the introduction was very important to how cement basically is fundamental to our construction industry and our buildings for the future. So from Mr. Henning, I wanted to ask you, tell us about the regional model for climate neutral cement in Germany.
Yes, good afternoon, everybody. Thank you for the invitation to the ARC panel today. The cement region, the region for climate neutral cement is located in my home area, Westphalia, which is some 150 kilometers from here, and there we have about 25% of the complete cement production in Germany. And we have all the engineering companies building machinery for cement processing in the area, a lot of jobs, a lot of innovation. And the idea for that region climate neutral cement Westphalia was to preserve this cement production plants, these engineering companies, but the main point is we have so much potential to save CO2 over there. About 7%, you all know that, 7% of the CO2 made by man is processed by cement, and we can save so much CO2, and we want to bring that together. CO2 saving, jobs in engineering, jobs in cement production, and for that we need acceptance in the society, acceptance for CCU and CCS, because we all know we only can make cement climate neutral when we make CCU and CCS, especially CCS. And so we need acceptance in the society and in politics for CCS, and this is a big job of that round table. We bring together all the actors, cement production, engineering, pipeline operators, science, NGOs, and politicians like me. Yeah, this we have just started. We have been implemented in the coalition contract of the North Rhine-Westphalian coalition of Christ Democrats and Greens, and there we want to implement this climate neutral region, Cement Westphalia. So, thank you very much. This is the idea of that roundtable.
Okay, thank you. We would like to hear more about the roundtable at a later stage. And here on our panelists, it's CEOs and founders of innovations in cement industry. So I just wanted to briefly ask them to introduce themselves and introduce their work that they're doing, and to briefly explain their innovations and what it entails, what are the disadvantages and what are the advantages of this new innovation in the cement market. Yes, thank you, Ms. Steph.
Hello everyone, I'm delighted to be here. Yes, so we are developing Ecolog Materials. Ecolog Materials is a CO2 negative concrete admix material, which helps to turn concrete into carbon sinks and improve the functional characteristics of the concrete. And the key ingredient, maybe to your question how it works, the key ingredient that we are using is biocarbon. Biocarbon is basically a sequestered carbon coming from residue biomass, any waste really from food processing or agriculture or the forestry industry. And it's basically the idea that you avoid the carbon being released back into the atmosphere at the plant's lifetime. You solidify it into a like permanent material, and this is then what we are refining further and putting into concrete.
Thank you.
Yeah. Hi everyone. Thanks for having me. So yeah, I'm Barney. I'm one of the co-founders of Ceratec, and we're doing, I guess, sort of something similar. I guess these all sound sort of similar, but it's carbon negative cement replacement material. So the term was mentioned earlier, supplementary cementitious material, which is something that, as the cement is hydrating and hardening in your concrete, provides a secondary reaction to help increase strength. And so examples would be something like fly ash or blast furnace slag, which the industry use at the moment to mitigate some of the emissions, because you're just using less cement in general. So we produce a material that's very similar to those, but we produce it intentionally. It's not a waste product, and we do that in a way that sequesters more carbon than it releases. So we're sort of tackling the cement thing on two fronts. We can sequester the emissions from the kiln, and we can also replace some of the cement in the concrete mix to get your overall concrete down to almost carbon neutral, plus or minus 5%, something like that.
All right, yeah, my name is Andreas. Thanks for having me. We are a bit behind that value chain, so we are starting also with material science, taking different SEM materials to produce concrete for a product that is used for building houses, basically a building block system. So far, we are not in the carbon neutral sector, or we haven't reached carbon neutrality, because going into or bringing materials into the construction or into building houses is quite complex in terms of regulation. But what we are doing basically is we're trying to use those materials worldwide in different markets to drive the decarbonization of cement or of concrete, let's say it like this, and then to use those materials in a circular economy. So we're creating a building block system that can be disassembled again and reused. And so we try to mitigate two challenges on the supply chain side, using materials that we call, let's say, waste or secondary raw materials, and then on the building side to make buildings designed for disassembly, rather than that we have to destroy buildings again and face the same issues over time again and again. Because if you look into the building industry, it's organized in a very linear way. We take material, we build something, and then we destroy it. And once we have destroyed, we sit in front of the stuff and try to separate the materials again so they can be actually recycled, which takes a lot of energy and effort these days. So these are the two elements that we try to tackle.
Thank you very much for the explanations. I think that it's also very important to talk about like scalability of the innovations that you have brought forward. In terms of Andreas, you guys work with geopolymers, and what does, in terms of quantifiable numbers, what does that mean for cement emissions reductions, in terms of even talking about the fact that you focus on the supply chain and the reduction, and like what is the scalability, and what is your reach, or what is also your aspirations for the reach that you'd like to have? Is it geographically in Germany, or can it also function outside of Germany?
It does. It has to function outside of Germany. We just heard about the scale of the construction industry worldwide. I think it's around 50 billion tons of concrete that is produced per year. That is massive. And we have to find solutions that work globally, like cement does work globally right now. For other areas or other regions in this world, we have a lot of opportunities, for example, to use these fly ashes and slags as they actually end up on landfill today. Here in Germany, it's a bit different. It's almost completely recycled or used. So there's a lot of opportunity, let's say, in African markets, but also in Southeast Asia. And from there, there's specifically where we need to build as global society massively is basically in Africa and Southeast Asia. We can also find very much of clay, which can be calcined much more sustainable than we can do with what we do with cement today. So if you look at the mass balance, what do we have today when we want to replace cement completely? The fly ash slag systems, they can maybe replace 10 to 15% of the cement. So it's a technology that is viable now, and it's economic viable. We also work with that. But to reach a higher scale than that, you need to find, or you need to diversify your raw material supply chain, and you need to be more flexible in terms of technologies for production.
Similar question.
Yeah, so I guess in terms of scalability, I require some sort of suspension of disbelief to, pretend, because at the moment I still make it by hand in the lab in like a big barrel. So you have to look way into the future for actually having an impact. But if you just look purely at cement replacement numbers, we can go as high in our trial samples as 40% replacement of the cement. And 95% of the emissions in your concrete come from the cement. So, if you're doing that for a big old block of concrete, then that will have about a 40% reduction in overall CO2. And that's before you've taken into account the fact that the process itself is also consuming CO2 emissions. So if you want to lump that in with the overall, then obviously you're going from 40 way up, because the process itself is carbon negative. In terms of location, the raw materials that we use are sort of metal silicates, so magnesium silicates, calcium silicates from waste concrete. And both of those things are found all over the place. You know, magnesium silicates make up like 80% of the world's crust or something like that. So it's kind of throw a rock and it'll hit magnesium silicate, and probably be magnesium silicate actually, I suppose. So there's a lot of it, and it's fairly well distributed. I mean, it's the same reason that we like limestone so much, is there's a lot of it and it's well distributed. Specific geographies that are of interest to us, I think India actually has a limestone shortage and absolutely tons and tons of magnesium silicate, so that would be a prime location. Anywhere where you've got a cement kiln and magnesium silicates and a source of CO2, you can operate this process. You know, it doesn't require particularly complicated bits of kit. Like I say, I use a paint mixer, like one of those handheld ones. So it's really not a complicated job. So in terms of scalability, yeah, I mean, it'd take a while to knock 40% plus off the entire cement industry, but that would kind of be the goal, I suppose.
For us, as I mentioned, we are using waste biomass. That's kind of the feedstock for our key ingredient, the biocarbon. Most people think about residue wood, so that is all of the sawmill dust and all of these residue that remains from the forestry and working with wood, which currently is about 1 gigaton per year globally. Additionally, there's lots of additional feedstocks, which we actually think is much more interesting, and we are also really trying to develop for our materials, which, if you think, is something like rice husk or manure or sewage sludge or nutshells or all of these things, and then we are looking at quantities which are more closer to 2 to 5 gigatons annually of like new residue biomass. So in terms of scalability, there is a lot available, and obviously it's coming up every year again. The other important thing for us, obviously, is the biochar production and the market there. In Europe, that is currently growing 80% year over year. So last year we had about 130 plants online in Europe. This year it will be already 180, and it's strongly growing. So also there should not be a shortage. Also the size of the individual plants are growing. In the beginning it was like output was a couple of 100 tons. Now we are in the 5,000 plus tons of output per plant. So I would say that's kind of the key drivers in terms of scalability. Our ambition is to have half a gigaton of CO2 removal impact by 2030.
Okay, great, thank you so much. And I wanted to also ask a related question that also ties back into you, Hennings, is that in terms of these are great innovations that you have on the market. Some are not on the market yet, but they you want them to be. In terms of from the regulation side, from the norms and the standards that exist or policies that exist, what challenges are you facing, or what limitations in general, maybe not even in terms of policy, but what limitations do the admixtures, do the supplementary cementatious materials have? Because Bonnie, you said that it's 40% in the lab. That is quite a high percentage of replacement. So I wanted to ask, you see that, but what other limitations are you seeing? Or also like, I guess, opportunities as well in terms of what else can be implemented. And then for you, Hennings, in relation to how they answer, what are the policy measures or the regulatory measures that you have been taking place in terms of this model for regional climate neutrality, and how do we move from ordinary Portland cement to the innovation that our panelists are proposing? Yes, thank you.
Yeah, so in terms of the amount of replacement that you can put into concrete, it depends on two things. I guess what you're trying to replace it with and what the regulations say. So even assuming you've got some brilliant replacement material that is essentially the same as cement. In fact, you could look at it under a microscope and do all of the relevant tests and it would come back as cement. Well, I mean, I can only really speak for the British standards here, but I know that there are a lot of parallels with the European standards. So all of that being a given, you wouldn't be allowed to put any of it in your concrete and use it for building unless you have gone through design assisted by testing, and then that's only specific for one project. And you can maybe do a concrete products thing where they do performance-based testing. That's the American system. But for us, the standards are quite prescriptive in terms of what you can and can't put in cement and how much of what you can and can't put cement you can put into it. It really depends, I think, basically on how much calcium is in your supplementary cementitious material. So, for example, blast furnace slag has got so much calcium and alumina in it that it's very close to being cement. You know, it would almost set on its own with water, given half a chance. It doesn't. You can alkali activate it in a geopolymer, but it just needs a tiny bit more. If it had a tiny bit more calcium, it would set with water, and then it would be like cement. Something like fly ash has got less alkali species in it, so you can do less replacement because it's not as reactive, it's not as similar to cement. And then something like our material actually has no alkali in it at all, or alumina for that matter. It's like 99% amorphous silica. Thankfully, the standards are written in a way that means that it's basically the same as fly ash. And there are a couple of, I mean, you have to look into it, and it's like there are rules stacked on top of rules stacked on top of rules, right? So it might look like you can replace something with something, and it turns out you can't, or vice versa. So we've had some conversations with the Mineral Products Association, who are the people that make these decisions in the UK. And you basically go to them and say, oh, what if we do this, this, and call it this? And they go, no. You say, well, if we do this, this, and call it this, you go, oh yeah, that might work. Same material, going in at the same replacement level, but it just depends on how you sell it, I suppose. But yeah, 40% isn't unreasonable, I don't think. I mean, 40% that's 5% more than you're allowed in EN 1971 for a fly ash, I think. But so the limit we really go to is 35%. It's just 40 is the highest we've tested.
From our point of view, like you said, what is technically possible is something very different what is viable in the market from a customer point of view or application point of view or economic point of view. And that's why I think changing the construction industry is more like an evolution, less a revolution. Hopefully revolution will come, but it is a long-term, and it's a long-term walk. For regulations, I think actually more is possible than you think. But you have to find your hacks, and with these hacks, you have to have a first foot in the market, and then you have to create a new reality. Because only when you create new realities, regulation will move on. It's the same with other innovations, where innovation is faster than regulation. We see it in the digital space, we see it in the mobility space. So you have to make new facts, and then that's the only way how to give regulation an idea where the road can go to. And I think this is the phase that we are working in right now, or that we are in right now. And we have to work all together. That's also, I think, a difference, or a very different model that we have to create all together. It is much more a mode of collaboration and cooperation, Meanwhile, in the concrete or construction industry, this was not the mode of working. Yeah? It was more like I create my own regional monopole in the market, and this is how I earn my money. But this does not foster the development that we need very urgently. Otherwise, we will not meet any targets in the next years or decades.
Thanks. Yeah, fully agree with what has been said. I think the norm compliance and certification is the key factor that stops any innovative material right now, because actually when you talk to like real estate developers, architects, they are fine with trying new materials. They are also fine with the green premium to which a lot of us can operate. So in the end, it's always the certification that stops of actually implementing this, and then you have to find these types of niche markets or niche products or loopholes where you can demonstrate the technology already outside of the laboratories. They do exist, which is good, but it's a lot of effort of finding them, and it stops from real scale fast, which we require to really have climate impact soon enough. And I think there are some good initiatives out there. The Alliance for Low Carbon Concrete and Cement, which Bellona, for example, is part and leading, is one example where a lot of like innovators get together and try to move in Europe the system of like ingredient-based and very descriptive norms to performance-based norms, and I think that would probably be the largest lever for us at this point.
I think it is important to go both paths. The one is to replace cement in concrete, and to decarbonize cement production, and we have to combine both. You have talked about the norms and all these regulation. This is important to be changed quickly, and we have to create a public demand for this new concrete, which will be a little bit more expensive than concrete we have today. And as the public sector is about 20% of the demand, total demand of cement and concrete, we have an instrument that public building sector, housing, streets, railway, windmills could be used to get kind of credit points. When you build your house with climate neutral cement, which is more expensive, you get credit points and you get subsidies for that. So this is one idea. You have to create a market. The regulation that has to be changed are named by my co-panelists, and I would like to add the regulation for CCU and CCS, which is not been regulated now in Germany at all. We don't have the possibility to make CCU and CCS, but we want that. We have to do that, and we have to make our law comparable to Scandinavian neighbors like Denmark or Norway, where they allow CCS, and it would be a big step for Germany to put our captured carbon dioxide into pipelines to Scandinavia and put it under the sea. And this is the most important task we have in German politics at the moment. And I hope the government in Berlin will do that, will accept that, and will make the way free for CCS in Germany to our neighbor countries.
Thank you for that. I think one of some of the highlights that I got from the conversation is that we are moving forward. So the cement industry and the construction industry is not as stagnant as it was 50 or 60 years ago. And we do have more prescriptive standards and norms and regulations, and we need more flexibility in terms of them, and also more or the addition of CCS and CCU into the system so that we can have more options, right? So that is like very important. One of, that is actually coming to an end of our session. We have 10 minutes for questions open to anyone in the audience.
Thank you. So I heard that in the production and consumption of cement, also the sand is a problem because it's a limited substance. So I was also thinking that it's not only about replacing something in the production or also in the material, but also maybe reducing the usage of cement. Or are there other solutions? Because yeah, if there's a limited supply of sand also, it's not the only problem with the CO2, right?
Thanks for the question. So we are actually, with our material, Ecolog materials, also replacing the sand, 20 to 30%, because obviously with biodiversity being the next big crisis, this is a very, very big topic. I think it's not top of mind for a lot of people in the real estate or construction industry yet, because you have to kind of tackle one issue at a time, and right now carbon is the big topic. But yeah, for sure, that's super important, and I think obviously there are more obvious ways like building less, refurbishing, repurposing buildings, doing more maintenance, these types of things. But also I think it's about new materials also replacing sand.
And I think one very important thing is how much recycling material do we want to put into concrete. This is very complicated in Germany because the quality of recycling material has to be very high, and so a lot of chances, a lot of potential to introduce recycling material is not used. So this is a big task to for the complete science and for the economy and for the environmentalists to find a better way to introduce recycling material into the concrete.
Say something about this. Because this is not a science issue; it's a regulation issue. Yes, look to Switzerland or to the Netherlands. Our Dutch friends, they buy all the construction rubble because they integrate it into their concrete to get more points in public tender. All of that from North Rhine-Westphalia. So technically, it's not a problem. We can create concretes made of 95% secondary raw materials. If you look into construction rubble in Europe alone, that's 850 million tons of construction rubble that could be recycled, but we don't use it. So it's almost enough material for concrete to not use sand or what's the other aggregate? Sand and the bigger ones, the gravel. Yeah, sorry. So if you just look at the mass balance in Europe, you could create a circular economy today, and in Germany definitely, because we take down so much material. I would assume at least 60-70%, or we could run with an 80% ratio. So that's not a technical problem. It is something on the regulation side, and I'm sure there's a lot of lobbying going on in that area.
May I ask a question? Who do you think is lobbying most? Is it the cement lobby, or is it the environmental lobby who says it has to be absolutely clean, these recycling material?
To make it very short, I think there are some interests in the aggregate industry here in Germany. Because we still have some natural resources and companies want to exploit. So there's a very much fundamental economic interest behind. Many people say we don't have a sand issue in Germany. Yeah, that maybe that's true for the next 2 decades. I heard we already importing gravel from the northern countries actually, because we are short of that already. But this person is right. If you look into the world supply chain for sand, it's a big issue. And look into India, look into North Africa, look into even China. So this is going to be a big issue, and we have to solve this, and the only solution is circular economy.
This is the right keyword for me. I'm Thomas. I'm from Circular Valley Foundation here in Wuppertal. And hi, Andreas. Your Polycare is one of our alumni in the batch number 1, so 2 years ago. Our target is very easy to make this Rhine-Ruhr metropolitan region the Silicon Valley for circular economy and the transformation within the next 10 years. So that, and we do that with supporting startups and also bringing a network with scientific and industrial partners here, running very well. But my question was on your statement on innovation. I hope I got you right. You said innovation should be in front of regulation, just to set maybe new pre-standards that could be then regulated afterwards. I would see it differently in some cases, with even 32 years industry experience, that sometimes it's quite helpful to have a regulation out that comes in 5 or 10 years, let's say 10 years, and to give enough time that various technologies, also the famous discussion of technology openness is then not a topic. And you say, okay, we want to be, let's say, have concrete with only 50% CO2 footprint, and in 20 years it's 0. And now the race is on. Or you say with 50% recyclate, and then the race is on. And there might be some technologies to watch and also to certify for, let's say, other things that it works. So it's not only about footprint and recycled content. But what about your opinion on that idea? So just to end up with, I'm an industry guy. I'm not a politician regulatory fan, but in some cases, regulatory is the root cause for a lot of innovation.
I'll have a go. I mean, I think that would be amazing, and I think there is some stuff happening in the UK at least. So our standards, the BSI standards, and they're trying to introduce something called BSI Flex or BSI Flexi. It's one of those two. But I think it only goes sort of part way to what you're saying, because it's more like, okay, this is what we've currently got, and we're going to allow you some wiggle room, as opposed to going the whole way and saying this is actually now a target that we want to aim for, which I agree, I would love to see something like that.
We have that question in traffic as well, in transport, about the question which motor should be the motor of the future, e-mobility or combustion engine. And we, as Christian Democrats, say just set the target and let the engineers invent the best solution. And this should also be the case in cement and concrete. Set a target and let the engineers invent solutions.
We have time for. You want to answer?
Yeah, I have a slightly different opinion, because I think technology openness is nice, but we also need some certainty. If we always keep our options open, then we don't really progress enough, because obviously every technology requires resources, and if we don't at some point put some technologies out of the race, the resources are always so widely spread that nothing really moves forward. And I think that's an issue right now. We have a little bit, everyone, if you see a lot of technology roadmaps and decarbonization roadmaps of cement companies, they are okay, let's do nothing and test everything and then 2040 we do CCUS, and then we mysteriously decarbonize within 10 years and are net zero. And that's just not how it works. Like, we need to decarbonize sooner, and I think we need to consolidate resources sooner on some really promising technologies rather than trying everything.
We have time for one more question.
Georg Jela from German Watch. It's really essential to address these technical and regulatory aspects you brought forward so far, but especially in terms of the circularity aspects, but also about the new binding materials. I wonder how far you might also have looked into the logistical aspects and the labor-related aspects, because if we build with a wider mix and therefore making construction more complex, you will need different training, different skills, and probably also different wages in the construction sector in there, because otherwise all these solutions won't fly. And I would be curious if some of you might already have some insight and some knowledge about this in there, because I so far did not encounter any discussion about this and how to address these issues.
So I think a really good example of that is, you might have heard of SEM-free, which is an alternative to concrete. They use it's geopolymer based, so blast furnace slag and an alkali activator. And it's great, and they obviously do really big pours coming out of the back of the wagons, so that's 8 tons, I think, in one of those. But they can only do it at the start or the end of the day, because if you try and put normal concrete in a wagon that's just had geopolymer concrete in it, it will flash set, and then you've got a wagon full of set concrete, which you can't then use to make more concrete. With regards to sort of, I guess, like, working conditions is a bit of a weird way to phrase it, but if you're using geopolymer concrete, then you have to use special gloves and wear special PPE, because you're not just using water, you have to use 10 molar sodium hydroxide or something, which is dangerous. So there's a lot of upskilling required around some technologies for sure. I think it would be good if we can try and aim for I guess practices to not change too much, because invariably, as you said, the construction is a very linear game, right? So in order to get the person in the middle to change doing something, then you have to get the person before and the person after to change how they do their thing as well. So it becomes tricky. So I think trying to operate within relatively understood timeframes is good, because otherwise it's like if you tell a contractor that you will have to wait 2 days to strike your formwork instead of 1, they will tell you to leave in less polite language, basically, because it affects the program too much, and then all of a sudden the block of flats takes 4 weeks to build instead of 2 weeks to build, and it's very hard. Like, there's a lot of jeopardy involved in trying to change that too much, I think. So I think technology has to take that into account and try not to rock the boat too much too fast, basically, because there are people on the ground that have to learn to use these technologies and take that into account.
Yeah, I can add something on that. Construction is very complex, correct? So there's an opportunity to make it easier. Yeah. So, but it's not a question of the material; it's the question of the process and product design. So this is why we try to combine material science, production technologies, and product design. And I could teach you tomorrow to be a masonry, and we could build a similar room like this in a week together. So this is taking out complexity of the building process, but using a product that has a much better property, basically. So you have to always think about taking out complexity, then the business case also on site gets much better, and you end up having a better, more affordable solution compared to the conventional, and everybody is widen up their eyes. And this is the only way how you can win tenders or projects.
Okay, so Andreas has promised us to show us how to build a house tomorrow. So tomorrow we are here, and that is the first thing we do. Final notes?
Yeah, we would like to have more people like Andreas, because we have to build up so much buildings and bridges in North Rhine-Westphalia, which are all very much concrete intensive, and it would be a very good idea to make them cheaper, to make them quicker and cheaper, and this is the big challenge we have. Building has become so expensive in the last months that the building of houses is nearly zero at the moment, and we need 400,000 houses or flats in Germany per year, new flats, and this is a very big challenge. When we can do that quicker and cheaper, it would be a very good idea. Let's talk together.
We have come to the end of our panel discussion. I wanted to thank our panelists for very insightful thoughts and solutions, because I think these types of conversations are obviously important for Germany and for the rest of the world. And I also noted that there is we need to strike a balance between regulation and innovation. And I don't think we have that yet, because if we did, we would be progressing faster than we are currently. So I think that from here, we need to continue these discussions and continue these forums and platforms to just discuss it more and to know how to do it. Thank you to our panelists, and thank you for joining us. Told you it's the best session. Thank you.